So what we're doing is we're solving rational equations, all right? So yesterday when we did this, we can type these into Desmos. This is one equation, this is the other, and then we can see where those two graphs cross each other. Where these two cross, that's our solution. The fraction that we get when we solve it by hand is going to be the same as that. Okay, so that's how you would put it in your or in Desmos. The left-hand side is one line, y equals. The right-hand side is another line, and then look for where they cross each other. All right. Okay, so now to solve this, what we do is we got to find the least common denominator. And really, that's the toughest thing to be able to find. Okay. So to find the LCD, what you do is you're going to take these denominators, and if any of them can be factored, you're going to factor them. All right. So to get the LCD on this, I'm going to take 2x. And since that's a multiplication there, that's really two factors. One is a 2 and the other one is an x. Okay, so I have a 2 and I have an x. All right, now the next denominator is an x plus 1. Now, neither of those are individual factors. X is not a factor in this case because it's being added to 1. And the same reason 1 is not a factor because it's being added to x. So to get the LCD of this, or the least common multiple, least common denominator, same thing, these are all unique. Okay, there's not another number or there's not another x term in this. The three of them are unique. So to get the LCD, you just take the product of all three. That's going to be my least common denominator. Okay, now just to show you the difference, okay, let's say there was another fraction in it, and this fraction had, its denominator was 6x squared. 6x squared. It was another denominator. Okay, so then what I would add to that list is a 6 and an x squared. All right, now to get the LCD, okay, the 2 and the 6 are both numbers. So I'm thinking, okay, what's the least common multiple between 2 and 6? Well, 6 is. Okay, if I look at my multiples of 2, 2, 4, 6, multiples of 6, 6, 12, 18. Okay, 6 is the smallest number that's in both lists. Okay, now, so that's the least common multiple of 2 and 6 is 6. Okay, now you've got an x and you got an x squared. So the least common multiple of that is the larger power, x squared. Okay, and now the x plus 1, it's unique, it's by itself. So we multiply by the unique factor. And then that would be our least common denominator. All right, so we'll do that as we go through this. Now, to solve this, you're going to multiply the left side by this value, and you're going to multiply the right side by it. Okay, so I'm going to take the left side of my equation, and the right side of my equation, bigger for you guys, easier to see. Okay, so there's the left side. And the right side. And I'm going to multiply both of those by the least common denominator. And the effect of doing that is it gets rid of your fractions. So to get rid of your fractions, we're going to distribute. This first term is going to get multiplied by this, and then the second term. Okay. So the way that the canceling works, the way that we get rid of the denominator is, okay, the 2x in this denominator cancels out the 2x up here, so I'm left with x plus 1 times 3. So the first multiplication is going to give me 3 times x plus 1. Okay, now I'm going to take the second term and multiply it by this 2x, x plus 1. So in this case, the x plus 1s are going to cancel, and I'm going to be left with 2x times negative 2x, or negative 2x times 2x, doesn't matter. So that would be negative 4x squared. All right, so now no fractions. Okay, and then over here, okay, I'd have this part would be negative 4x times x plus 1. And now from here, it's distribute, get your like terms together, and solve for the variable. All right, so now it's just manipulating using algebra. Okay, so these cancel. And I get 1 is negative. Oh, wait a minute. I forgot. I made a mistake up here, guys. When you distribute this 3, this should be 3x plus 3. 3x plus 3. So this is going to be 3, and this is going to be negative 7x. And then I'm going to divide by negative 7. And my answer is negative 3/7. And when we compare that to the graph that we got, it's the same thing. Okay, so that fraction right there, or that decimal, okay, negative 3 divided by 7, okay, it's the same. Okay, that right there is the same as 0.429. So that's my solution. And remember back up here where we said excluded values? Well, negative 3/7 isn't part of these excluded values, so that's another way we know that's the answer. All right, let's take a look at the next one here. All right. All right, so the first thing is excluded values. That's whatever makes the denominators zero. Okay, so in this case, if x was a zero, this denominator would be zero. So that's not allowed. And the same value would make this denominator zero. So that gets excluded. All right, now to get the common denominator, I'm going to take each one of these. So that denominator is 5x. So 5 is a factor and x is a factor. Okay, the denominator of this 1 is just 1, so I don't need that. And then the denominator of this factor is x, which I've already listed. Okay, this was from the first one, this was from the second one. All right, these are the same. So when we do our LCD, all right, these are the same thing, so they have to be part of my least common denominator, and then the leftover factor is 5. Now, just to show you a difference here, guys, because this is the part that usually gets people confused. Let's say that the problem was a little bit different, and instead of this x being x, it was x cubed. So now you would have x cubed. So these are the same factor. You take the larger of the powers, and that's what's part of your least common denominator. Okay, let's say that this was 20. So now I have 20 in this list. So now the least common denominator between 5 and 20 is 20x cubed. Okay, now instead of that 20, let's say that it was 3. Okay, now the least common denominator would be, well, the least common multiple of 5 and 3 is 15x cubed. Okay. All right, in our case, it's 5x. All right, so we're going to multiply everything by 5x and simplify it. All right, now I do my multiplication. So on the left-hand side, those cancel. I get rid of my fraction. Okay, now on the right-hand side, I'm going to distribute. So I got 5x times 1, 5x, minus. Okay, now when I do this one, the x's cancel, and I end up with 1 times 5, which is just 5. and I get x is 11 fifths. Okay, now when we check this one on Desmos, okay, for the left-hand side, I wrote y equals 6 fifths. And then on the right-hand side, I wrote y equals 1 minus 1 over x. And now I'm going to look at where those cross. Okay, they cross at 2.2, which is the same as 11 divided by 5. Okay, all right. Let's see, third example. So this would be page, I guess, 31. So I got x over 15 plus 1 over 3x equals 2 fifths. Okay. So first, what are the excluded values? Just 0. That would make this denominator 0. So we know that x can't be, if we end up with a 0, we won't count it. Okay, now let's do the LCD. So I got 15. Since these are being multiplied, I got a 3 and an x, and then I got a 5. So the least common multiple between 5, 3, and 15 is 15. And then anything left over, I put into the least common denominator. In this case, it's x. All right, that's my LCD. Now it's just a matter of doing the multiplication. And okay, putting it over 1, it just shows you that it's on the top. You don't really need to do that. Okay, and now start cancel. Multiply, I'm going to distribute. The 15s will cancel. And I just got x times x. So that's going to end up being x squared. Okay, now multiply those two. 3x goes into 15x 5 times. So that just becomes 5 times 1. Okay, and then over here, 5 goes into 15x, 3x. So that I would have 6x. Now this is a quadratic, so we're going to end up with 2 solutions. So I'm going to move the 6 over and then factor it. Okay. Okay, the numbers have to multiply to be positive 5 and add together to be negative 6. So that's going to be a negative 5 and a negative 1. So once we factor this, we're going to have x minus 5 and x minus 1. Okay, so my two solutions are, what makes this 0? 5. What makes this 0? 1. And that's my two answers. Neither of those are on my excluded list. And if we looked at the graph, you'll see there's two intersections on this one. Okay, the left side, the right side, and there's one intersection at 1 and another intersection at x equals 5. All right, the last one for solving equations. Okay, so that's going to be okay, x over x plus 3 plus 1 over 4 equals x over 2x plus 6. All right, so first, excluded values. Okay, negative 3 would make this denominator 0. Okay, over here, if x was also negative 3, you'd have 2 times negative 3 plus 6, that would be 0. So that is your only restricted value. That can't be an answer. Okay, now the LCD. All right, so neither of these are factors. Together, it's a factor because they're being added. So x isn't a factor and neither is 3. Okay, then you've got a 4. Now remember what I said at the very beginning. You're going to always factor all of your denominators. So 2x plus 6 is the same as 2 times x plus 3. So that means 2 is a factor and x plus 3 is a factor. All right, so now to get my LCD, okay, the LCD between 2 and 4 is 4. The LCD between these two, well, they're the same. All right, now you would take the higher power. Well, the powers are the same, so that's going to be x plus 3. What I mean by the powers would be, let's say that this first question, this was x plus 3 to the 4th. Then this would be a 4. You take, when they're common, you take the larger power of the two. And now it's just doing a bunch of arithmetic. Or algebra, I should say. Let's see. Oops. All right, and then I start canceling. So cancel, cancel. So that first is going to be just 4 times x, so 4x. Okay, now when I multiply it by the second term, the 4's will cancel, and I'm going to have x plus 3 times 1, which is just x plus 3. Okay, and now over here, remember this 2x plus 6, this is really 2 times x plus 3. Okay, so the 2 is going to go in the 4 twice, and the x plus 3's are going to cancel. So over on this one, I'm just left with 2x. Okay, so here I'm going to get 5x. And then I'm going to solve that. I'm going to subtract 5x, so that's negative 3x. And then I'm going to divide by negative 3. And I get x equals negative 1. And if we graph those, that's where they would both cross. All right, now I know that's a lot of algebra and stuff. I'll look at here's the 2 graphs. And they cross, the x coordinate where they cross is negative 1.